through another example. Question 2. Water is flowing horizontally through a 250mm diameter pipe and into a constriction of 100mm diameter. The pressure difference is measured as 23.5mm of mercury. Using Bernoulli's theorem, calculate the rate of flow, and it gives you some data. The density of mercury is 13,600 kilograms per metre cubed, and the density of water is 1,000 kilograms a metre cubed, and G is 9.81. Now, what's the first thing you need to do? You need to write down Bernoulli's equation. Now, which formula? Now, the pressure energy here is quoted in metres head. Do you understand? Metres head. So the formula to apply is this one. Rho GZA plus rho GHA plus half rho VA squared equals rho GZB plus rho GHB plus half rho VB squared. That's the formula when it's metres head. Don't forget, draw a sketch. Put a sketch, it tells you what you're doing. This sketch here shows you point A and point B. Point A, you've got your diameter 250mm, you've got 100mm diameter at B. It tells you the pressure difference and the density of mercury at the top. So draw a sketch first. Now, where are you going to place the datum in this particular instance? Don't forget, horizontal pipe, place it down the middle. Why? Because you can delete the potential energy. There's no potential energy in the middle. Draw it down the middle, you can delete it, and it leaves you with this. Rho GZA plus half rho VA squared equals rho GZB plus half rho VB squared. Now we need to determine the velocity energy of the water using the continuity equation, which is Q equals VA. Now in this situation, can you see the problem you've got is you haven't got two known elements. You don't know two of them, you only know one of them. Yeah, you don't know the velocity and you don't know the quantity of water flowing. You only know the area. Now, whenever you get a situation using the continuity where you don't know two parameters, what you have to do is identify a relationship between the 2 points, and all you're going to do then is substitute it in. Do you understand? You're going to substitute it in. So any question you see and you think to yourself, well, I can't work out that because there's two unknowns. You need to get a relationship between the two. How much bigger is that than that? And then you substitute it in. Now this type of question comes up a lot, and it's trying to make sure you understand. If you've got two unknowns, you have to substitute in this relationship. So let's look at the relationship. Now Q equals VA, and if VAA equals VBAB, in other words, velocity times area at point A is the same as velocity at B times B. Now first of all, let's determine the area at the 2 points. So you work out the area at the 2 points using 0.7854 times d squared. As you can see, the area at point A equals 0.7854 times d squared, which gives you, it's 250 mil, so it's 0.25 times 0.25, it's 0.049085 metres squared. That's the area at point A. And the area at point B, it turns out, using the same formula, is 0.007854 metres squared. Now, if you divide them out, divide the top one by the second one, you find that the area at A is 6.25 times the area at B. Do you understand? You need this relationship. We know the area at A is 6.25 times the area at B. That's what we need to know. Now, if we know again, knowing this, that VAAA equals VBAB, you can also work out that if the velocity at point AB must be 6.25 times higher than the velocity at A, if the area at A is 6.25 times bigger than the area at B, the velocity at B, VB, must be 6 times bigger, 6.2 times bigger than the velocity at A. That's what you need to do. So in other words, VB, the velocity of the water at B, or the fluid at B, is 6.25 VA. That's what you need, that relationship. VB equals 6.25 VA. Now what you do is you substitute this principle in the formula. So what you get is this. Rho GZA plus half rho VA squared equals rho GZB plus half rho, brackets, you've got to put the brackets, 6.25 VA brackets squared. You've substituted in 6.25 VA instead of VB. You've substituted that in. Now, to carry on with the calculation, you've got to multiply the brackets out because the whole thing is squared. To get it out of the box, the brackets, you've got to do this. You square it. So it gives you rho GZA plus half rho VA squared equals rho GZB plus half rho 39.0625 times VA squared. Do you understand? You've multiplied this, you've got to square the 6.25 to get it out of the brackets. That gives you that formula. What do you do next? You transpose the formula. Don't forget, when you transpose a formula, all you do is whatever you do to one side, you do to the other. Now, in this case, to get rid of one of these known entities, you take away one of the rho VA squareds. You take it away. So instead of having 39.0625 at one end, what you do is you get this. It gives you rho GZA minus rho GZB equals half rho 38.0625. So what you've done is you've taken rho GZB out of one of the sides, so you've moved it across by taking it away, and you've taken away one of the velocity energies. So it gives you that formula. It's transposing, transposition. Now, the pressure difference in this problem is rho GZA minus rho GZB. So that's the pressure. That's the pressure energy, and that's the pressure difference. So rho GZA minus rho GZB is the pressure difference, isn't it? That's the pressure difference. Now, it tells you what the pressure difference is in millimetres of mercury on the head pressure. And it's the density of mercury is 13,600 kilograms per metre cubed. You replace this with the pressure energy. So take away rho GZA minus rho GZB. That's the pressure energy. Take all that away and substitute in the head of mercury, which is 13,600 times by G, which is 9.81, times in metres 0.0275. That's the pressure energy, that's the pressure difference. And that equals half rho 38.0625 VA squared. Do you understand? Now you've started to substitute in. If you multiply that out, it gives you 3,668.94 equals half rho 38.0625 VA squared. Transpose both sides, knowing the density of water is 1,000. If you divide both sides by 1,000, you can lose that density. That gives you 3.66894 equals a half times 38.0625 VA squared. To remove the half on the one side, you multiply both sides by 2. It gives you 7.33788 equals 38.0625 VA squared. Now, how do you transpose again? Divide both sides by 38.0625 gives you 0.192968 equals the square of the velocity at point A. And finally, square root both sides gives you VA equals 0.43928 metres a second. That is the velocity at A. Now we know the velocity at A, we can determine the rate of flow, because we know the rate of flow is Q equals VAAA. Now we know the VA, we know the AA, we can work out the rate of flow. Substitute in your known values, Q equals 0.43928 times 0.0490875 gives you 0.021563 metres cubed per second. And that's roughly 21 litres a second. And that is how you use Bernoulli's to solve problems involving flow. Now go through this again and try to understand it. But don't forget, if you've got two unknowns, you've got to substitute in a known a parameter. Yeah, you've got to substitute in a known parameter. And don't forget, pressure difference is, when we had before, rho GZA minus rho. That is the pressure difference, because sometimes the question will give you it in just the pressure difference. If it tells you the individual pressures, you just put them in either side of the equation. But if it tells you a pressure difference, move the 1 across to get it a minus, and then substitute that in with the pressure difference it gives you. That's how you use Bernoulli's. That completes question 2.